Okay, so for the first two, we've got these two different ray diagrams that we need to look at. And the first one, we have this lens, some objects sitting beyond the focal point and beyond the center of curvature. So here's our object right here. First question though is just, is this a concave or convex object? So here we see that the middle of the lens is the widest point as opposed to the end, so this would be a convex object. Is it convergent or divergent? Well, a convex lens is going to be convergent. C, is the focal point positive or negative? Well, the real side of a lens is going to be the right side. And so that's where the focal point is going to be. So this is going to be positive. And for the fourth one here, it asks us to go ahead and draw the ray diagram. So let's go ahead and do that. And so we'll take it through here. And remember, when we start drawing these ray diagrams, we start at the top of the object and we go kind of parallel with that principal axis, which is the solid line coming through the middle. Okay, so we go parallel to the middle of the lens, and then from there we go ahead and we pass through the focal point on the real side. Okay, so it should look something like this. That's for the first ray. For the second ray, we start at the top of that thing again. Okay, now that we're back, so for the second ray, we all start at the top of the object and we go through the absolute center of the lens. Okay, so when I say absolute center, I mean not only horizontally but the middle vertically as well. So that is the center. It's gone on through, and so what we have as a result is we have the location of the image. So I'm going to make the image color red, why not? And so that's going to be the image right there, H prime, where this is H. Okay, so is the image magnified or reduced? This is smaller than that one, so it's going to be reduced. And is the image real or virtual? Well, it's on the real side of the lens, so it's going to be a real image. Okay, that one's kind of easy. Let's go down and look at the second one, which is a little bit harder. Okay, so for the second one, we have a mirror instead of a lens, and looks like the object is sitting in between the focal point and the center of curvature. First question, once again, we just want to know, is it concave or convex? And this is a convex mirror because it doesn't cave in on itself. Is this convergent or divergent? Well, a convex lens is convergent, but a convex mirror is divergent. Okay. Is the focal point positive or negative? Well, the left is the real side for the mirror, and the focal point is actually going to be on the right hand side, so this is going to be considered a negative focal point. And now it's time for us to draw the ray diagrams. And these are going to be a little bit different than the ones that we did for the lens. I'm going to start off with green. So we go from the top of the object, once again parallel over, and make contact with the surface of the mirror. Okay. So that's not so different. Now it's a mirror, so the light is going to reflect off, right? It's not going to refract, it's going to reflect off, and the direction that it reflects off has to do with how the virtual part of the ray goes and interacts with the focal point. Okay. So the virtual part of the ray is going to actually come down here and touch the focal point, whereas the real part of the ray the color will change. It is going to, I kind of messed that up, but this should be absolutely in line with this. So it comes and it bounces off like that. Okay, same thing here. For our second ray, we always go towards the middle. Here we are at the middle, and then it reflects off at exactly the same angle that it touched at, right? But the virtual part of the ray continues on to the virtual side. So whereas this was the real ray, the virtual one is going to bounce up and be absolutely in line with the real one, meaning that when we go to find out where our image is, you see that our image is actually right there. Okay, so this would be H prime here, where this is H. Now, is the image magnified or reduced? Well, it's still reduced. We can obviously see that this is not as tall as the other one. But since it's on the virtual side of the mirror, the image itself is virtual. So that covers that.